Hi everyone and welcome back to another lab. In this lab, you will learn how to configure and verify IPv4 floating static routes. Floating static routes are backup routes that come into play when the primary route fails. These routes have a higher administrative distance than the primary route to ensure that they are only used if the primary route becomes unavailable. This lab will guide you through the configuration of floating static routes and demonstrate how to verify their operation. So by the end of this lab, you should be able to understand the concept of floating static routes and their role in network redundancy. You will also be able to configure primary and floating static routes on Cisco routers. Also, you will verify the operation of floating static routes using show commands and then test the failover mechanism by simulating a link failure. And we will do this by shutting down the primary interface that connects to the ISP1 router. So as usual, we will start with a simple explanation of what is floating static route and the purpose of using it. And then after that, we will go through the lab topology and the lab objectives and then the lab tasks. And then next, we will walk you through the lab solution. So first things first, what is floating static route? So a floating static route is a type of static route used primarily as a backup route in a network. This routing mechanism is configured with a higher administrative distance than the primary route, allowing the router to prefer the primary route while still retaining the backup option in case of a failure. The router will only utilize the floating static route when the primary route becomes unavailable. When a network path fails, such as a link going down or a device go down, the router can seamlessly switch to the floating static route without manual intervention. This redundancy enhances the reliability of the network, ensuring that communication can continue even if the primary path is disturbed. To configure a floating static route, it simply involves specifying the destination network, the subnet mask, the next hop address, and the higher administrative distance. Finally, floating static routes are particularly useful in environments where continuous connectivity is critical, as they provide a straightforward and effective way to maintain network stability. Okay, so with that being said, let's move into the lab topology, and I'm gonna open up my diagram. And as you can see on the screen here, we have a couple of sites. We have the headquarters sites, which is on the right hand side of the topology or the diagram, and the left hand side of the topology, you can see that this is related to branch 1 network. So if we look at the branch 1 site, we can see that there is a router connected to multiple networks. There are VLANs 201 and 202 that resides in branch 1 site. VLAN 201 has an IP address of 172.168.201.0/24, and VLAN 202 has an IP address of 172.168.202.0/24. We can see that PC1 and PC2 are connected to branch 1 switch 1, and we can see that branch 1 switch 1 is connected to branch 1 router 1 via gig ethernet 01. And similarly with PC3 and PC4 are connected to branch 1 switch 2, and branch 1 switch 2 is then connected back to branch 1 router 1 via gig ethernet 01. We can see that branch 1 router 1 is connected to the headquarter router 1 via the gig ethernet 0/0/0, which is the WAN interface or the WAN link. And the headquarter router 1 is connected to 5 different networks. We can see that within the headquarter site, there are a couple of VLANs as well. We can see VLAN 101 and VLAN 102. So VLAN 101 has an IP address of 172.168.101.0/24, whereas the VLAN 102 has an IP address of 172.168.102.0/24. We can see again that PC5 and PC6 are connected to the headquarter switch 1, which is then connected to the headquarter router 1 via gig ethernet 01. Similarly, on the other side, we can see antenna server 1 and antenna server 2 are connected to the headquarter switch 2, and the headquarter switch 2 is connected to the headquarter router 1 via gig ethernet 01. You also can see that headquarter router 1 is connected to a couple of ISPs. So the primary ISP is the link that is connected to ISP 1, which is gig ethernet 0/1/0. That would be the primary link. and the backup link, which is then connected to the ISP2, and that is via gig Ethernet 0/2/0. So in this lab, all end hosts are configured with the appropriate IP address settings and are good to go. Okay, so regarding the lab tasks, we will begin by performing some pre-checks to review the current configurations across all switches. We will verify VLAN assignments and ensure the proper operations of all connected interfaces. Next, we will move to step number 2 and step number 3, where we are going to proceed with basic configuration on the branch 1 router 1 as well as the headquarter router 1, where we will configure each connected interfaces with the appropriate IPv4 address settings. And once we have done all these configurations and all these configurations are in place, we will then conduct some connectivity tests to verify the initial setup. Following that, in step 4, we will configure a default static route on the branch 1 router 1 pointing to the headquarter router 1. Then on the headquarter router 1, we will configure a single static route that encompasses the networks used in the branch 1 site. And then after this, we will configure a default route on the headquarter router 1 that points to the ISP1 and also configure a floating static route that points to ISP2 as a backup. We will then move to step number 8, where we are going to examine the routing table and verify our configurations. Next, we move to step number 9, where we are going to perform connectivity tests between the end devices to confirm network communication is functioning as expected. Then we're going to move to step number 10, where we are going to perform a trace route from PC1 to the external server to determine which ISP the headquarter router 1 is using. And then after that, we're going to move to step number 11, where we are going to simulate a network failure, where we are going to disrupt the primary link connected to the ISP1 router and then return to PC1 to issue the traceroute command again to check which ISP is being used. Finally, we will restore the primary link, save the configuration across all devices, and conclude the lab. Okay, so this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. I have added the lab document in the video description so you can download it and practice at your own pace. I have also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. Okay, so I'm going to tackle the first task and I'm going to jump into each switch and verify the configuration to the end devices. So I'm going to start with the branch 1 switch 1. Then I'm going to go to the CLI and from there I should be able to issue the enable command to go to user privilege mode, and from there I could issue the show interfaces status. And you can see that fast Ethernet 01 and fast Ethernet 02 are connected to the PC1 and PC2 respectively. Both of these interfaces are connected, as you can see under the status, and also both of them are part of VLAN 201. Similarly, with gig Ethernet 0/1, this link is connected to branch 1 router 1. Right now is not connected. The reason being is because the other side of the link is admin down, and you can see that is part of VLAN 201. That means that VLAN is already been created on the switch and each interface is connected and is a member of the appropriate VLAN. Next, let's verify that each interface that is connected to the end device is configured with access mode. So I'm going to issue the command of show interface, and then I'm going to say fast Ethernet 0/1, and I'm going to say or include the word switch port, and then I'm going to say pipe include administrative mode. And as you can see, the administrative mode is set to static access, which means this interface is already configured with access mode. If I up arrow that and then change the fast Ethernet or the interface ID from fast Ethernet 01 to fast Ethernet 02, you can see that the other or the second link is also configured with static access. If I just for the sake of it, if I issue the show running command and then pipe section, and then let's say 0/1, and I'm going to include the $sign. You can see that the interface is being configured with switch port mode access command. Okay, so with that being done, let's jump quickly into branch 1 switch 2 and do the same thing. So here we can see that Fast Ethernet 01 and Fast Ethernet 02 are connected to PC3 and PC4 respectively. Both of these interfaces are connected and they are part of VLAN 202. Similarly, with Gig Ethernet 01, you can see that this interface is connected to branch 1 router 1 and is also part of VLAN 202 as well. Let's look at the current configuration for each interface. So if I say show run pipe section 0/0, sorry, actually I meant to say 0/1, and I'm going to include the $sign. You can see that this interface, Fast Ethernet 01, is connected to PC3 and is configured with switch port mode access. And the same applies for Gig Ethernet 01, which is connected to branch 1 router 1. If I up arrow that and change the interface ID from 01 to 02, you can see that 02 has similar configurations. Okay, so with that being done, let's jump into the headquarter switch 1. So again, you can see that Fast Ethernet 01, Fast Ethernet 02 are connected to PC5 and PC6 respectively. Each of these interfaces are part of VLAN 101. And similarly with Gig Ethernet 01, this interface you can see that is connected to headquarter router 1 and also is part of VLAN 101. Let's just quickly look at the running config. You can see the current configurations that is being applied or implemented under each of these interfaces. If I up arrow that and change the interface ID from 01 to 02, so you can see that the interface is being configured statically with access mode, and also the switch port is being assigned with VLAN 101, and also it has the right description as well. Finally, let's jump into the last switch. So I'm going to go to headquarter switch 2. And again, Fast Ethernet 01 is connected to Internet Server 1, and also Fast Ethernet 02 is connected to Internet Server 2. Both of these interfaces are part of VLAN 102, as you can see on the screen. And similarly with Gig Ethernet 01, you can see that this link is also connected to headquarter router 1 and is part of VLAN 102. If I look at the configuration quickly, you can see the Fast Ethernet 01. This is the configuration under that interface. And similarly with Gig Ethernet 01, you can see the current config as well. I will up arrow this and I'll just change the interface ID from 1 to 2. You can see that this is the configurations that has been applied or implemented under the interface Fast Ethernet 02. Next, we're going to jump into the second task where we would need to perform some basic configurations on branch 1 router 1. So I'll go back to my topology and I'll go to branch 1 router 1. I'll go to the CLI. And then the first thing that I'm going to do, I'm going to configure interface Gig Ethernet 01. That interface is connected to branch 1 switch 1. So I'm going to say interface Gig Ethernet 0/1. First things first, I'm going to set the description to link to branch 1 underscore switch 1. I will set the IP address. So I'm going to say IP address 172.16.201.10, and the subnet mask is going to be 24, which is 255.255.255.0. And I also need to enable the interface. So I'm going to say no shutdown. Next, I'm going to configure the interface that connects to branch 1 switch 2. So I'm going to up arrow multiple times. And then I'm going to change the interface ID from 0/1 to 0/0. And that interface is connected to branch 1 switch 2. So I'm going to set the description, and I'm going to change that from link to branch 1 switch 1 to link to branch 1 switch 2. I will also set the IP address. So I'm going to say IP address 172.16.202.10, and then I'm going to set the subnet mask, which is /24. And also I need to enable the interface. Next, I'm going to configure the interface that connects back to the headquarter router 1. So I will say interface, or actually I will up arrow that multiple times. And I will set the interface ID to 0/0/0. And then I will set the description. I'm going to say link to HQ_R1. Let's set the IP address. So that is going to be 10.0.0.2. And then I'm going to set the subnet mask to /30, which is 255.255.255.252. Next, we need to enable the interface. So I'm going to say no shot. And then I'm going to hit end. Next, let's perform some in-flight checks. So the first command that I want to execute is the show IP interface brief. And you can see that we have configured mainly 3 different interfaces. So we've configured gig Ethernet 0/0 with the IP address of 172.16.202.10. And you can see the current status is up state. Similarly, with the gig Ethernet 0/1 that is connected back to branch 1 switch 1 has an IP address of 172.16.201.10, and the current status is up as well. Finally, the interface that is then connected to the headquarter router 1 is configured with 10.0.0.2, and right now the status is down, and the reason being is because the other side of the link is admin down, but we're going to tackle that next. If we then look at the running config, so I'm going to say show running config or -config pipe section, and I'm going to say 0/1, and I'm going to include the $sign. You can see this is the configuration that has been implemented under interface gig Ethernet 01. And if I up arrow that and include the 0/0 ID, you can see right now that this is the configuration that we applied under gig Ethernet 0/0. And similarly with interface gig Ethernet 0/0/0, which is the interface that connects to headquarter router 1. Next, we are going to check some local connectivity between PC1, PC2, PC3, and PC4 and the default gateway. So I'll go back to my topology and I'll go to PC1. And then I'm going to go to desktop, and from there I can go to command prompt, and from there I can issue the IP config. You can see the current IPv4 address that is assigned to PC1 is 172.16.201.1, and you can see the default gateway is also being set. So if I issue the ping command to ping the default gateway, so I'm going to say ping 172.16.201.10, you can see that there is reachability to the default gateway, which means I should be able to reach PC2. So I'm going to say ping 172.16.201.2. You can see that I am able to ping PC2 as well. Let's try to ping PC3. So I'm going to up arrow that, and I'm going to change the IP address to 172.16.202 and then .3. And you can see we also have successful ping. Let's try to reach PC4. So at this stage, we can confirm that there is local communication or local connectivity between each device within branch 1. Next, let's jump into the headquarter router 1 router, and we are going to also perform some basic configuration, set some IPs across all the interfaces that are connected to different networks. So I'm going to go back to my topology, and I'll go to the headquarter router 1. And the first interface that I'm going to tackle is the Gig Ethernet 0/0. This interface is connected to headquarter switch 2. So I'm going to say interface Gig Ethernet 0/0. I will set the description and I'm going to say link to head or HQ underscore switch 2. Let's set the IP address to 172.16.102.10, and the subnet mask is going to be /24, which is straightforward. So it's 255.255.255.0, and then we will also need to enable the command. So I'm going to say no shutdown. Let's configure the interface Gig Ethernet 0/1, which is connected to headquarter switch 1. So I'm going to change the ID from 00 to 01. I will up arrow that to get the description command, and I will change the number 2 to 1. I will also up arrow that to get the IP address, and I'm going to change the third octet from 102 to 101. And then I will also enable the interface. So I'm going to say no shutdown. Next, I'm going to configure the interface that is connects back to branch 1 router 1. So I'm going to up arrow this and say interface Gig Ethernet 0/0/0. And then I'm going to set the description to branch 1 underscore router 1. I will set the IP address to 10.0.0.1 and the subnet mask is 255.255.255.252. I will also need to enable the interface, so I'm going to say no shut. Next, I need to configure the primary link that connects to the ISP1 router. So I'm going to say interface Gig Ethernet 0/1/0. I will set the description and I'll say link to ISP1. Let's set the IP address. So I'm going to say IP address 203.0.113.1, and the subnet mask is going to be 255.255.255.252. We will also enable the interface, so I'm going to say no shutdown. Next, I'm going to configure the interface that is connected to the ISP2 router. So I'm going to say interface Gig Ethernet 0/2/0. I will get the description command and I will change the description from link to ISP1 to link to ISP2. Let's set the IP address. I'm going to say IP address 198.51.100.1. And the subnet mask is going to be 255.255.255.252. And also I'm going to enable the interface. Now let's perform some in-flight checks. So I'm going to say show IP interface brief, and you can see the 5 different interfaces or 5 different networks that have been configured. All of them are in the up state, as you can see on the screen here. And each interface is configured with the appropriate IPv4 address settings. Next, let's verify the routing table. So I'm going to say show IP route. And as you can see on the screen here, we have 5 different networks. So the first network that we see is the 10.0.0.0/30. And the second network is the 172.16.101.0/24. And then the third network, which is 172.16.102.0/24. And the fourth network is 198.51.100.0/30. And then finally the 203.0.113.0/30. So this network is associated with the ISP1, which is the primary link to the internet. And this is the secondary network that is connected to ISP2. Next, we can actually look at the current configurations for each interface that we just configured. So I'm going to say show run pipe section 0/0, and I'm going to include the $sign. And you can see that this is the interface configuration for Gig Ethernet 0/0, and this is the configuration for Gig Ethernet 0/0/0. If I up arrow this and change the interface ID from 0/0 to 0/1, you can see this is the configurations for Gig Ethernet 0/1. And if I up arrow this, you can see that this is the configuration for the interface that is connected to ISP2. Next, let's verify the local connectivity between PC5, PC6, internal server 1 and internal server 2 with the default gateway, etc, etc, much like what we did with the branch 1 side. So I'll go back to my topology and I'll go to PC5, and from there I'll go to desktop and then command prompt. I will issue the IP config first, and again you can see this is the IPv4 settings that has been assigned to that PC. And what I will do, I will ping the default gateway first, so I'm going to say ping 172.16.101.10. And as you can see on the screen, we have connectivity to the default gateway, which means I should be able to reach PC6. So I'm going to say ping 172.16.101.6. And I'm able to ping PC6 as well. Now let's verify connectivity to internal server 1 and internal server 2. So I'm going to up arrow this, and I will change the third octet to 102, and the fourth octet would be 101 for internal server 1. And as you can see, we have reachability to internal server 1. Let's check the connectivity to internal server 2. And again, we have reachability between all end devices within the headquarter site. Next, I'm going to jump into step number 4, where we are requested to configure a default route for unknown or external networks, with the next hop address being set to the headquarter router 1 IP address. So let's do that. Actually, before we do that, let's examine the routing table. So I'm going to issue the do show IP route command. And right now you can see that the default gateway has not been set. So what we can do, I can say IP route 0.0.0.0, and then let's set the subnet mask with 0.0.0.0, and also set the next hop address, which is 10.0.0.1. And then I'm going to hit enter, and let's just verify that quickly. So I'm going to say do show IP route, and you can see that there is a new entry has been added for a static default route. And you can see that the gateway of last resort has been set to any network or unknown network. So the next hop would be 10.0.0.1, which is the IP address that has been assigned on the headquarter router 1 interface that is connected to branch 1 router 1. Okay, next I'm going to jump into step number 5. So I will need to go back to headquarter router 1. So I will go to headquarter router 1, and I'm going to go to global config. And in order for us to configure a single static route to cover both networks, which are 172.16.201.0/24, as well as 172.16.202.0/24, we must use a summary route to include both networks. And in order for us to do that, we will need to issue this command. So I'm going to say IP route 172.16.200 or 200.0, and then we are going to use this subnet mask, which is 255.255.252.0. So this subnet mask that I'm using is /22, and that will ensure that both networks will be part of this summary route. And then I will set the next hop address to 10.0.0.2. I'm going to hit end, and then I will issue show IP route. And you can see that there is a new entry has been implemented or added in the routing table. And this entry is related to the network that is being used on the branch 1 site. Next, let's jump into step number 6, where we are requested to configure a default route with the next hop address set to the ISP1. And with that being said, I'm going to go to configure terminal and I will issue the IP route command, and I will set a default route with 0.0.0.0 and then the subnet mask 0.0.0.0, and I'm going to set the next hop address, which is the ISP1 router. So I'm going to say 203.0.113.2. At this point, since I want this to be the primary default static route, I would leave it as is, because by default, the administrative distance for a static route is 1, and the lower the administrative distance, the more believable the route is. So I'm going to hit enter, and then I will hit end, and then I will issue the show IP route again. And right now you can see the default gateway has been set to this network. And also you can see that there is a new entry in the routing table, which indicates that if there is any unknown traffic or any unknown destination, we have to use this next hop address. You can see that the administrative distance is set to 1. Next, let's jump into step number 7. And step number 7, we are required to configure a default route with the next hop address set to the ISP2. And remember, this is the floating static route that we are going to configure, because we are going to configure it with a higher administrative distance than the default value. So I will show you what I mean. So I'm going to go to configure terminal, and from here I will say IP route 0.0.0.0 and then 0.0.0.0, and then I'll set the next hop address with 198.51.100.2, and then if I question mark that to reveal the content sensitive help, you can see that I have got the option of adding a distance metric for this route. And as I mentioned earlier, the default value for the administrative distance for any static route is set to 1. So according to the playbook, we would need to set the metric to 10. So I'm going to say 10 and conclude the command with 10, and then I will hit enter. And then if I hit end, if I were to reveal the current config, if I say show run pipe include route, you can see that I've configured 3 different static routes. And if I were to reveal the routing table, so I'm going to say show IP route, you can see that the default static route that is still being implemented is the one that is pointing to ISP1. And if you were to examine the routing table, you will not be able to find the second route, which what we configured here, as you can see on the screen here. Okay, so what we're going to do next, we are going to perform some connectivity tests to make sure that PC1 is able to ping PC3. They are from a completely different sites. So we want to make sure that PC1 is able to talk to PC3. We also want to make sure that PC1 is also being able to talk to PC5 and antenna server 1. Once we have done this and the ping is successful, we can then initiate another ping from PC1 to the external server and make sure that we are using the right or appropriate path. So I'll go back to my topology and I'll go back to my PC1 interface. So the first test that I'm going to do, I'm going to make sure that PC1 is able to reach PC3. So I'm going to say ping 172.16.202.3. And you can see that PC1 is able to ping PC3 successfully. Next, let's try to ping PC5. So I'm going to up arrow this and I'm going to change the IP address to 172.16.101.5. And as you can see on the screen, we have reachability and connectivity to PC5. Let's do the same thing for PC6. We also have reachability to PC6. Let's try to reach antenna server 1. So I'm going to up arrow that and I will change the IP address to 102. And I'm going to say .101. That's antenna server 1. And then I'm going to ping the antenna server 2. And as you can see on the screen, we have reachability and accessibility. Now let's perform one last ping where we need to make sure that PC1 is able to reach the external server. So I'm going to say ping 10.10.10.10. Okay, so it looks like we had a multiple time out. So let's up arrow this again and just make sure that we have reachability. We can see that there is reachability and connectivity between PC1 all the way to the external server. Okay, so what I'm going to do next, I'm going to use the traceroute command on PC1. So I'm going to say trace rt and I'm going to say 10.10.10.10. And as you can see on the screen, if we look at the third entry from the output, you can see that we are using the ISP1 router because the third hop is saying that we are using 203.0.113.2. If I go back to my topology, you can see this is the IP address that we are using for ISP1. So what I'm going to do next, I'll go back to my headquarter router 1 and I will mimic or I will simulate a link failure. And this, by the way, covers step number 11. So I'll go to config terminal and I will go to interface config mode. So I'm going to say interface gig ethernet 0/1/0. And if I just do this, and what I will do, I will initiate a continuous ping. So I'm going to say ping -n and I'm going to say 100 and I will put the IP address of the external server, which is 10.10.10.10, and then I will hit enter. And you can see that I'm trying to communicate with the external server right now as we speak. And what I will do on the second screen, I'm going to actually shut down the link. And you can see that we have lost one packet here, as you can see on the screen. So I'm going to cancel this. And what I'll do, I will up arrow this multiple times to get to the traceroute command and I will hit enter. And you can see if we were to look at the third entry of the output, we can see that the IP address that is being used this time is 198.51.100.2, which is the ISP2 IP address. So this confirms that the floating route is actually working. If I go back to my headquarter router 1 and say do show IP route. Now you can see that the static route that is being installed is the static route that we configured with administrative distance 10. And as you can see on the screen here, this administrative distance has been set to 10. And you can see that this is pointing to the second ISP, which is the backup ISP. So we have verified and confirmed that the floating static route is working. I will say no shot. And if I go back to my PC and up arrow multiple times to get to the ping, you can see that we are able to reach that server now. So I'm going to cancel that and I will up arrow that to get to the traceroute command. And if we were to look at the output again, you can see that the third entry of the output is pointing back to the ISP1, which is the primary route. And if I go back to my router and up arrow this multiple times to get to the do show IP route command, you can see that the primary default static route has been implemented back into the routing table. Okay, so that's it folks for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Please remember, consistency and hands-on practice are key to success, so stay curious, stay inspired, and until next time, peace.